Okay. Hello, everybody. Okay, it's afternoon class. Um, the schedule says I have to go 3 hours, but I really doubt whether I can go that far. Yeah. Anyway, so I just posted the updated PDF made from my PowerPoint. Okay, so I'll just go through those. Okay. All right. So in the morning, we went through the rough picture of the different grip robots, right? Okay, and the differences are basically finger, the structure of the finger. Here is the one grip robots here, okay? And when it's grabbing something, the finger looks like this, okay? It has only one air chamber with air passway, and it has roughly two layers. One is the finger layer, and at the bottom there is a flexible but not extendable paper layer, right? And if we see this from the side, okay, the side view of the cross section of the finger from the side view is basically big air chamber connected by the air passway. And obviously we have a very thick finger spine, if I say so, okay, finger spine. Then when the air is blown in, inside pressure will build up, and that inside pressure will start pushing up the spine. And this spine part is basically elastic, viscoelastic, and can be flexible and can be elongated, right? So if you keep pressuring the inside, then eventually the spine will go up. And because of that, this bottom not extendable, non-extendable paper layer will be bented this way, right? That's the idea, okay? All right, and this person created the mold using this very simple cardboard, okay, because this is a 3-finger robot. So he first created the Y-shaped walls, inside created created and glued blocks of the air chambers, right? Okay, and connect the blocks of the air chambers with the grooves. And these are presumably the air passway, right? Once everything is created, then pour in the silicon mixture and remove the silicon mixture, so on and so forth. Good. All right, and second one is the similar, but a little bit more sophisticated finger robot. Okay, cross section is roughly about the same. Okay, as you can see on the bottom picture, when the air is completely blown into the finger, as you can see, fingers are blowing up, okay, bloated, and you can see 1 cell, 2 air chamber cell, 3, 4. You can see we can clearly see the 4 air chamber cells getting big because of the pressurized air. Good. So the mechanism is you blow in the air, okay, just like the first one, the internal pressure will gradually push up the top wall. In this case, the top wall is not as thick as the previous one. The reason is at the final stage, at the bottom picture here, each cell, air chamber cell, is completely pressurized and expanded, and each cell will turn into, from the rectangle, turn into, from this picture, it's not obvious, but from this picture on the left, lower left, you can see each cell is turning into sort of sector shape, triangular shape, or trapezoidal shape, right? Then once that happens to each cell will push each other, and because of that, lower surface will flex. Good. All right, this is the second finger, okay, and this is the mold used by the second robot, okay? And the last one is the more sophisticated finger robot. this one, each cell has a separate chamber like this, okay, right? And looks like this. And the air is blown into here. Then each independent cell will again pressurized and bloated, okay, get bigger and turn into this picture lower left. You can see originally rectangular shaped cell is turning into a sector shape or inverted triangle or inverted trapezoidal shape. Then once that happens, each cell will push each other. Then finally the finger will bend, right? Okay, and this example I talked in the morning was, this one I think uses the second type finger robot, okay? But clever thing about this robot is by connecting front, you can see the two finger, back it has two finger, in the center it's a body, but it's also a finger robot. By connecting them, serial manner, pressurizing them using different tube at different pressuring rate, then you can turn this into a crawling human robot. Good? Okay, so basically if you understand this, if you understand the mechanism of this or even this, okay, and connecting one of these or multiple of these together, you can create very creative, interesting robot. Okay, so in my view, as I said before, I'm not a robot expert, but after going through these web pages and YouTubes, I noticed the toughest part here is the how to create this mode, design this mode. Okay, so I will go through how to design these mode using SolidWorks. Then once that's done, you can print out as the STL file or something, then print out using the 3D printer. Once 3D printed mode is done, then you can pour the silicon mixture, take it out, done, right? Good. So this afternoon, we will talk about how to make this using the SolidWorks. Okay. All right. Here we go. And the SolidWorks, what I know is there is a 2019 version SolidWorks you can access in the E1223 room. Okay, all computers has the SolidWorks 2019. Okay, and I know all computer can started with Chinese version or English version. So when you start, you have to right click and say English version or Chinese version when you log in, okay? If you log in with Chinese version, then everything, all windows shows Chinese character. Because of that, SolidWorks, all the commands appears as Chinese, okay? All right, and but today I'm going to use the English terminology. So if you are okay with my instruction, then you may need to start window using the English version. Then once English version window is started, then you can start the SolidWorks. Then SolidWorks will show you everything in English. Good. So that's one way to access SolidWorks. Okay. And or you can download free version, trial version. Okay. Usually trial version is 30 days free. Okay. All right. And one of those. Or you're a very super rich person and you have already owned your own copy. That's great for you. Good for you. Okay. But one big problem is SolidWorks is very picky about the version. Okay. So next week you will start designing the mode or whatever. Okay. And if you're okay with SolidWorks, okay. If you're more AutoCAD person, then you can use AutoCAD. Or there is a online version 3D CAD program called Onshape. Okay, that one is completely free, and it's very much like SolidWorks. Okay, so anyway, I'll suggest one of those. But if you, after today's presentation, you're okay with SolidWorks, then you have to be careful one thing. Okay, SolidWorks is picky about the version. Okay, if you're using the school version, the ME version is the SolidWorks 19 that can be found in E1223 computer room. Then you can use it, and your friend, your teammate has to use it. Otherwise, your file and your friend's file cannot be shared. Okay, if you want to share, either use 2019 version or download the 2023 version, free version, trial version, and use it. Otherwise, you get stuck, right? That's the small warning. All right. So the first one, grip, right? Grip. First one, we are going to create this one, okay? All right, usually SolidWorks, to create the mold, you have to go through two parts, okay? All right, the first part is, let's see. No, I don't think so. I don't want to start the, okay. Two parts. First part is design the part first, then put the part into a solid block, okay? Embed the part into a block, then after that, dissolve those parts and create the empty mold. So that's the two steps usually, all right? However, grip 1 and grip 2, the shape is simple enough, okay? And also the time to create the original part and put that one into a solid block and dissolve everything inside to create the mold block part takes about the same time. So might as well create the mold as is in the first shot. So today we are going to, in this one, we'll create this mold first. Okay, once this is done, you can print it out. Clearly, this is the base, right? You pour in the mixture, then you can cure it, take it out, then that is your finger. Got it? All right. Okay, and basically I'll go through, okay, you start the SolidWorks. SolidWorks has two parts, okay? Actually, three parts. One is the 3D part creation tool. And once that's done, you can combine 3D parts by using the assembly mode. Then once it's done, if you want to project the parts into a 2D drawing, then you can start the drawing. Okay, but we do not care about the drawing today. We'll use the parts, okay? And later we will use the assembly. Good, right? So basically, we will create the mold using the part function, all right? Then first thing you have to worry about is unit, okay? My computer, this system is US system, so it will start, default setting is inch and pound. So you have to change the unit using the option to millimeter, gram, seconds. Okay, that's what I'm going to go through. Once that's done, use the top plane. Okay, because all the molds basically will be sitting on the flat top. So it's a good idea to use the flat plane. Okay, all right, put the origin. It's nice to have an origin. Okay, put the reference line called center line. Okay, once that's done, because the first finger robot has Y-shaped fingers, so I'm going to draw Y-shaped reference line, or I should call this as a center line at the angles. Okay, 60 from the vertical line, 60 from the vertical line, then automatically three lines will be 120 degree apart using the smart dimension. Okay, then after that, I'm going to start each finger first by tilted finger by adding the tilt lines, okay, make them same length, parallel to each other by using this reference line, okay. Then after that, add this side line, add the relation, because this purple line, tilt purple line and side line should be perpendicular to each other. So add the perpendicular relation to this and this, this and this. Okay. All right. Then after that, I'm going to add a vertical rectangle here, okay, and make this empty. Then finally, I will add the dimensions. Good. Once everything is done, oh, sorry. And finally, I will close. Right now, this sketch line is not closed. So finally, I will add one more line, vertical line here to close it. When the area is closed, then this gray shaded area will appear. Once this happens, SolidWorks means we can add thickness to turn it into 3D object. So from here, we will use a tool called extrude, then add the thickness. Now you can see the one side of the parts is created. Once that's done, then I can mirror it, sort of copy this one side of the parts onto the other side using the mirror tool. Then finally, you have the Y-shaped object. Good. All right, from here, how can I create a hollow base, right? Then SolidWorks has a shell feature. Okay, start the shell feature. Okay, you have to tell the SolidWorks, we would like to, from where you want to dig this base. Of course, we would like to dig from the top. So starting face is the top face, and also tell what kind of thickness we want. I don't remember. I said 10 millimeter or so. Indicate the thickness. Then click yes, then bus tab will show up. Good. All right. Then now I have to add the air chamber. Okay, by create the block, put the air chamber in, and put the air duct in, right? So I'm going to put the rectangular air chamber, a very thin rectangular air passway here. It's nice to have a reference line. So select this bottom surface, turn into blue. Then I added reference line called center line. Okay. All right. Using this, I can draw a rectangle. Okay, one side, create a rectangle. No, actually, I did the center rectangle and define the dimension, define the location of the center of the rectangle from this origin. Okay, then I added the thickness, used extrude. Okay, the thickness appeared. Right. Now I have to add this duct air passway. Okay, to do so, I have to create a thin rectangle 1 times, 2 times, okay, and remove the center line by trim tool. Okay, now we have rectangle sketched on the flat surface. Then add the thickness, 5 millimeter in this case. Then you have air duct. The solid air duct is created. Okay, here we go. Now I would like to copy this 1 time, 2 times, right? Okay, of course you can keep repeating the same thing on this tilted surface, but that's kind of annoying. So it is a good idea to copy this 1 time, 2 times, right? Using the circular pattern mode, okay? To create, because this copy is created in a circular pattern, so I need a round object or axis. So on this tiny area, before move on to here, I sketched vertical reference line. Okay, so once that's done, I can go to the circular pattern under linear pattern. Then it will show up here. Okay, and say I would like to copy this and this, these 2 objects from here. Okay, here's the axis. Okay, axis is the sketch. This is called sketch 4. So that will act as my sketch axis of rotation. Usually, equal space is selected, 360 is selected. Since I have total copy is including the original one, 1, 2, 3. So I say 3, then automatically show you 1 and 3, and say yes, that's done. Good. That's the way SolidWorks work. All right. Okay, that's the picture. All right, here we go. All right, so to start it, you have to go to home, Good. Because I'm creating one part, right? So part. All right, here we go. And make sure the unit we're using is not the inch pound. You can use the inch pound, but since we live in Taiwan, right? So unit should be centimeter or meter, but our object is smaller, so I use millimeter. Go to option. The option shows up. Good. And the unit, we have to set the unit. Unit is in this document property. Click the unit. Aha, see, my default setting is IPS. Okay, so I have to change to millimeter, gram, second, and say, okay. If you want, this one shows the number you key in will show up to second digit. So if that's not detailed enough, we can change this to 3-digit too. But in our case, I don't think we need it. Okay, so unit is set. Good. All right. As I said, all the modes will be sitting on the flat top. So we should sketch everything on the top plane, right? Good. Right. And it will be all usually the starting presentation is 3D isometric, right? It clearly rectangle top plane is viewed from 45 degrees. That's why we see sort of tilted plane, correct? Then we would like to see from the top. So then you have to come here and say normal view. Good. All right. Okay. Then it's always a nice idea to have a origin presented in the center. So click this eye and this guy is the origin. Then origin shows up. Good. All right. Then first, I would like to have a reference line. Okay. If you're okay with sketching the tilt line directly, no, actually, you shouldn't. You should still sketch the vertical and horizontal line. Okay. Feature, right now in the feature mode, feature is the action you can take place to create 3D object, meaning adding thickness, so on and so forth. But sketching is the 2D maneuver. All the sketch tool is hidden in this bar. Good. All right. First, we would like to draw the reference line. Okay. Here's the line. If you click it, okay, you can see line, oops, line, center line, okay, midpoint line. I actually have never used midpoint line. Okay. Right. Okay. But we would like to draw center line. That is the reference line. So do not use the line unless you are sure you want to draw, define the area. In that case, you can use the line. Okay. If you want a rough sketch reference line, then you have to use this center line. Good. All right. Come here. Draw it. Make sure it's horizontal, right? When it's horizontal, this yellow box with minus sign shows up. Good. Escape. Okay. All right. One more line. Again, center line. Okay. Vertical. Once it's vertical, there will be a yellow box with vertical eye shows up. Then yes. Okay. Escape. Right. And as you may have noticed, originally 2 lines were blue, now turn into black. Everything is black means fully defined. Can we move on to next maneuver? Okay. All right. Then now I'm going to draw a tilted line. Okay. Maybe one more vertical line. Why don't I draw one more vertical lines? Again, it's a reference line, so center line. Okay. All right. Can I ask you one thing? Have you used SolidWorks before? So I bet you use the AutoCAD. Inventor, oh, that's originally called AutoCAD, isn't it? Now it's called Inventor, right? Yeah. Yeah. True. I learned AutoCAD last century. So, you know, now I'm more familiar with the SolidWorks. And if I'm not wrong, Inventor has this kind of feature too, right? You can draw sketch, 3D sketch. So if you know the Inventor, AutoCAD, and you're comfortable with it, and if you Google it, you should be able to find out how to create the mold using the Inventor. That's okay too. All right. Here we go. Now I'm going to add the tilt reference line called center line here. Okay, so here we go. Starting from the center, click it. All right, sideways. Okay. All right, good. Unlike the horizontal and vertical, this one needs the angle definition, so it's not fully defined. That's why it's blue, right? Okay, now we need this to be 60 degree from the top, 60 degree or 30 degree from the horizontal. Either way is fine. Okay, so to add the angle dimension, go to the smart dimension here, click it, okay, and click first line to second line. Hold on. Angle shows up, right? Okay, then tap it. Then I can change this into 60. Done. What happened? Okay, as you can see, 60 and 60 is in. That means this tilted reference line is completely defined. Starting from the origin, angle is defined, so it's completely defined. Good. All right, so that's why it's black. Now I'm going to add the tilt line. Okay, now it's not the reference line anymore. So I need to use the lines, okay? Okay, all right. Then now we need to add the relations. One thing we know is these two lines should be parallel to with respect to this tilted reference line. So we have to add that relationship. Okay, on top of that, later we'll add these two lines are equal. That's another relationship. Okay, so adding relationship here. Good. So I'm going to add the parallel relationship by selecting this, this, okay? So to select the line, it's like just like a Microsoft product, right? First one is just left click. Next two item has to be shift click. I completely forgot. Yeah, right. So 3 lines are selected. Good. All right, then we have to add the relationship of parallel. Okay, and say yes. Good. And also, what else? What else do I have to say? These two, this and this should be equal. So I have to select this. Okay. Two lines are selected and both of them should be equal. But here you go. Okay. And the same distance? Same distance. Oh, it's okay. All right, then I'm going to add one more line here to the side. Okay. Good. And this line should be vertical to each other here. Applies a vertical relationship here by selecting these two line. Okay, two lines selected, apply vertical. Oops, daisies, what happened? What happened? Wait a minute, am I skipping one position? Sorry. Okay. Yeah, I added the perpendicular. Yeah, equal. Well, let's see. Why it's not working this time? Okay. Okay. Let's see. Apply the vertical. It's not allowing me to do this. Yeah. Oh, that's right. Perpendicular. You're right. Thanks. I should have added the perpendicular, isn't it? Yeah, makes sense. Thanks. Stupid on me. So it's perpendicular, so it shows up. Now I'm going to add the relationship to this. Again, perpendicular. Sorry. Thanks for the suggestion. All right, good. So it's perpendicular now. All right, then I'm going to add a rectangle down here. Okay, so I'm going to, what did I do? Okay, I'm going to add a rectangle here. Okay, corner rectangle. Good. Okay. All right. And clearly, this is an area already. I don't want this to happen. Okay. So I have to remove this line and this line so that I will have this as a silhouette. So to remove this vertical line here and vertical line, we have to use this scissors called trim entity. Okay. Then now I have a scissor to remove this, come here and click it. Okay. And the one more piece is here, click it. Okay. I think I have one more line here, right? Good. All right. So it's cleaner. Good. Okay. Then I think we can add the dimension. Okay. What was the dimension I added? Okay. I added 100, 20, 20, 100, 100. Okay. Good. Okay. So now I'm going to add the dimension. Okay. All right. So Okay, so I did 20, 20 here. Okay, and this is black, right? Because we have defined the relationship saying this and this is parallel and same length. So I just need to key in here 100. This is fully defined here. Okay, all right. And oops. Okay, all right. So everything is turned into black. So that means we can move on to the next stage. Okay, I will close it because this is not the area yet. So to close it, I have to add one more line from here. Good. Okay, so it's closed. All right, so I have created sort of weird shaped area. Okay, it's everything is black, so everything is fully defined. So that means I can add thickness to it. And I think I added the thickness. What was the thickness? 20. Okay, 20. So to add the thickness, you come here to feature. And at the thickness, you use extruded both extrusion. All right. So SolidWorks will automatically so tilt it. And right now, 20 millimeter is 10 millimeter is added. Okay. I'll change to 20. Right. So thickness changed to 20. Good. If you're happy. Okay. Blind is the direction of the adding thickness. You can see here is the arrow. That's the direction. Good. All right. Okay. Then let's review it from the top. Maybe I think that's a good idea. Okay, this is what I have. So if I can create exactly the same thing on the left-hand side, copy it to the left-hand side and make it a one piece. Good. All right. And since we're creating a symmetric object, okay, so that is called mirroring. Okay. All right. So it's a 3D maneuver, so we should be still here. You can see this mirror here. Click it. All right. All right. Features to be mirrored. Features says, okay, if you click this one, tree shows up. Okay, shows everything what we did. Okay. If you click here, sketch shows up. But anyway, we have only created one boss extrude 3D object here. Okay. So clearly we can only mirror this guy and this is sitting here. All right. Okay, now we would like to mirror this one with respect to the line is okay. So I'm going to select this and say edge here. Oh, no. I will use the right plane or, sorry, allow me to back up a little bit. Okay, these tools are sitting here already and quite convenient. Okay, these will allow you to rotate the object. Okay, and this will allow you to, okay, slide object. Good. So these are usually not here, at least in the piece, the SolidWorks in the ME Computer Laboratory. To add this, you have to go to here. Okay, oh, no. We have to go to here. Okay, customize it. Okay, and the menu, was it? No, shortcuts. Sorry, it was in command. And if you go to view, then you can see this and this sitting here. So if you want this to be on the workspace, you have to click this and move this onto the surface. Good. All right. Since I have it, I'm not going to do it again. All right. So use this one. Okay. Because clearly what we should do is mirror this entire object with this respect to this space face, right? So that's why I had to tilt it. Okay. All right. Mirror this. Okay. Features to be mirrored is the object. Okay. Mirror surface should be here. Good. All right. Finally, object is mirrored. So I say yes. Done. Good. All right. So now I am here. Okay. Right now it's a solid object. Okay. I would like to turn this into a bus. Okay. So to do this, we will use a shell feature. Okay. All right. So here we go. Let's see it from we can see it from the top, or we can see it from isometric view. Okay, good. All right. Right. So we would like to using shell feature to dig this object. So use the shell. Okay. And the starting face is this surface. Okay. Thickness is 10 millimeter. I think it's okay. I think I used 10 millimeter. Maybe a little bit too thick. Okay. What did I say? I think I used 10 millimeter, right? Okay. Oh, 3 millimeter. 3 millimeter, sorry. So I should turn into a 3 and say yes. Yeah. Okay. All right. Now we have a bus. Okay. Great. Of course, if you pour in the mixture right now, you only get the Y shape, right? That's not good enough. Okay. We need to have a air chamber. So that means I have to create the solid air chamber here. I also need a air pathway. So that means I have to create a solid air pathway here. Good. All right. So that's what we are going to do to sketch those things on this surface. Okay. Let's view it from the top, normal. Good. All right. Again, it's nice to have a reference line. Reference line is a 2D maneuver, so I have to go back to this switch. Okay. I'm going to put down the microphone and put the good. Vertical reference line is given. Okay. I can use this reference line to draw a rectangle, center rectangle. This is more easier to use usually. Good. All right. Then I have to add the dimension. What was the dimension? Oh, okay. Length is 60, width is 20. Center of this rectangle needs to be 70 from here. Okay. So those things using the smart dimension. Okay. Base rectangle is sketched and everything is black because that means shape is defined, location is clearly defined. So now you can add the thickness. All right. What's the thickness I added? Was 10. Okay, 10. All right. Then we will go to the feature, extruded boss or base boss extrusion. All right. Okay. Then we will add here to 10. Okay. And done. Okay, let's check it from the sorry, isometric view. Yep, the thickness is added. Okay, now I have to add the air pathway. Okay. All right. Again, it's a good idea to okay, I added the reference line, right? Next step is, okay, center rectangle is okay, but I use the corner rectangle to draw one thin rectangle one side and another side and define the dimension and yada, yada, yada. Okay, that's what I did. Then remove the lines in the center to create the rectangular area and added the thickness. Good, two rectangular is sketched. Now I have to connect to them. Oh, maybe I can leave it as is because area is defined. Okay, an area is defined. So maybe I can leave it as is. I don't need to remove this line. Okay, if you want to remove the line, you can use this trim to remove this center line. Yeah, two lines removed. Again, by doing so, we have a clean area. Okay, all right, then we can add the thickness, 5 mm thickness. Okay. Cannot be used for feature because of endpoint is wrong. Shared what? Wait a minute. What did I do wrong? Okay, then I will go back one and go back one. Okay, let's see whether I can extrude this way. Okay. Huh. Sketch cannot be used for feature because of an endpoint is wrong shared by multiple entities. Okay. Can I review it? Okay, let's see whether I can. Okay, I selected it. Huh. Why is that? Okay. Okay, then I will clean up this line. Okay, then do the corner rectangle again. Right, area looks okay to me. It is fully defined, right? Okay. Huh. I'll be damned. Okay, then why don't I? Sorry about the mistakes. Okay, then I have to, what's the best way? What's the dimension here? Let's use this center. All right. Hopefully this will work. It's giving me an error already. Yeah, okay, created, good. All right, sorry about the mistakes. Okay, all right, so if we see this, okay, from the top, okay, I have an air chamber block air pathway block created. Now I would like to copy this once, twice, 3 times around the clock, okay? To do so, I need a axis of rotation, okay? So I need to sketch axis of rotation somewhere here, all right? So I'm going to blow up this one, okay? And view this. Okay. Good. Let's try it. There is axis here. Maybe I can grab this one. All right. So I'm going to copy this by circular pattern. Okay. Somebody was saying something, I think. Okay. All right. So I'm going to use the circular pattern hiding under the linear pattern. All right. And what do I want to copy? I want to copy this one and this one, right? So click it. Okay. Is that one and this one, 2 of them. Okay. And axis of rotation is, can I grab this? Oh, great. I was able to grab that axis. Okay. Now it says equal space 360. So you can see 1 copy, 2 copy, 3 copy. That's not right. So I have to say 3, right? That's showing up this way. Good. However, my chamber is short. Okay, it is done, but whoa, so I couldn't do it. I shouldn't have done it. So I should have drawn a line here. That's weird. Okay. All right, then I have to select this surface. Good. All right. And the rebuild. Okay. I have the sketch line, I think. Where did it go? Where did it go? Oh, where did it go? It's not saved. One more time. Okay, so I will use this as the reference line, no, axis of rotation. Okay. To make a round copy. Okay, so now I have to go to the feature. I have to rebuild it. Okay. All right. Good. Linear pattern, circular pattern. Okay, I would like to grab these 2 blocks, this and this. Axis of rotation is actually the sketch 5. Good. All right, 360 degrees, 3 copies. Done. All right, then let's see it from the top again. All right, that's it. Good. So this is the mode. Sorry for wasting so much time. Good. And that's it. Basically, this is the way Well, of course, I bet nobody will use this because this is the most simplest form of the robot. Okay. All right. The next one. Okay. Let's try this one. Okay. This finger, maybe many of us may use, right? So this one is actually sounds weird, but much easier because this is the close, horizontal and vertical, right? Let's try to make this one, make a mode directory. Okay. To do so, what I'm going to do is draw a reference line, draw a center rectangle, remove the unwanted line here. Now I have an area, then add the dimension, okay, 120, 120, 50, and then add the thickness, 50, then I have a cross block, okay. Once that's done, going through the shell to dig everything out. Once that's done, I'm going to add these air chamber cell, rectangle here, add the thickness, okay. Then finally add the air duct rectangle, okay, add the thickness, then copy this thing. Oh, actually I created the circle, right? I think I created the circular cell here, then copy the everything around this center 4 times to create this. Good. All right, let's see. Hopefully this one will be smoother. Okay. All right, so I don't need this. All right, so next one. Okay, grip 2. Click the home. Since this is a one part model, so click the part. Okay, and we would like to sketch everything on the top plane. See from the normal view. Okay, again, it's a good idea to have a origin. And since this is a new start, I have a feeling I have to set the unit again. Yeah, that's right. Okay. All right. So do I need the reference line? Do I need the reference line? Maybe I don't need. Okay, I'm going to draw a center rectangle, horizontal and vertical one. Okay. All right, and clearly these lines are overlapping. I have to remove it so that we can create the cross-shaped area. To remove it, use the trim entity. Okay, 1 here, 2 here, 3 here, 4, 5, 6, 7, 8, 9, 7. Okay, good. All right, so lines removed. Now it's a completely open cross space. Good. All right, then I can add the dimension. Okay, dimension was 120, was it? 120 and 50. Good. Okay, so come here to add the dimension. Okay. All right. Everything is black, right? So that means this is ready. This is a well-defined 2D space. So that means I can add the thickness. Good. To add the thickness, we come here. First one. Okay. And I will add thickness that is 50. Okay, so 50. Okay, done. All right. Okay, now I have a solid cross shape. Okay, and since I want to make a mold, it has a bus top shape, so I have to dig it out. Okay, in SolidWorks, we can use the shell feature. So click this one. Okay, and what was thickness? 5 mm. Okay, so I have to starting from this surface, right? Okay, the idea is shell is you have to define from which surface you want to start digging. So from the top surface, so select the surface and select the thickness here. Okay, all right, then done. Good. So bus stub is given. Now I have to create the chambers. 1, 2, 3, all of them are same size. The first one is located 15 from the bottom, and second one is located 30, 30. Good. And to do so, again, it's a nice idea to have a reference line. So I'm going to draw a reference line. View this from the top is easier. Okay. Select this surface, sketch center line. All right, good. Okay, make sure you understand the difference between center line and line. Good. All right, then I'm going to blow up a little bit. Yes, I will blow up a little bit so that I can see things a little bit better. Okay. All right, then draw 3 center rectangle. Okay, all right, then define the shape. Okay, 25, 10, 10, 10. Okay, got it. Okay. Good. Shapes are defined. Location is 15, 30, 30. Okay. Good. All right, done. Everything is black. That means fully defined. Now I can add the thickness by using the feature extrude boss. Okay, and the thickness will be 40. Good. Now finally I have to add the chamber here. Okay. All right. Air duct. So again, one more time. Reference line. Maybe there is a clever way to do this. Rectangle. Yeah, a rectangle. Can I do this? I don't know. I should have, I forgot the one, add one circle here. Okay, so add the circle. Okay, and the diameter of this one is the 40. Okay, height is 40. Good. All right, add the dimension here. Sorry. It was 8. Okay, then at the height, that should be 40. Good. Done. All right, then finally we will add the rectangle to create the chamber. I'm also using the corner rectangle. Let's see. Hopefully this time I get lucky. Okay. And this will should be 4. Remove this line here by trim lines. It's really hard to use it by one hand. Okay, good. And the another rectangle, corner rectangle. Okay, then remove the center line again, trim it. Good. All right, so I think everything is defined now. Okay. All right. Okay, and the thickness will be 8, I think. All right, so I have a duct showed up, air chamber 1, 2, 3. Now I would like to create this copy of this to 1, 2, 3, 4 times, okay, around this tiny cylinder. So we use the circular pattern, okay, and created is extrude 4 is the air pass that we just created, but I would like to include these 2 chambers too. So that's extrude 2, okay? And that should be happening around this circular edge circle. Hold on. Okay, and should be 4. All right, done. Great. So that's the way we can create the second model, right? Okay, and of course, I think none of us will create a 4-finger robot, but part of the finger can be used for our robot, right? So that's the another way. Okay, then last one, I will talk about how to make snake robot that Professor Lin was presenting. Okay, this snake robot has a top portion with air chamber, air chamber, air chamber, and bottom portion is the scale, okay, with carved legs, okay? Right, I'm not done with the top modeling, so I will just show you how to create the lower part, okay? And use that to create a mold, right? And I think that will be quite plenty, and I'm getting tired too. All right, so I'm just going to talk about the lower part, okay? Once I'm done with the top portion, I will post it and so that you can use it next time. All right, so how to create the snake scale leg. All right, so basically, okay, what I'm going to do is I could have used the top plane, but I used the front plane to create the thin rectangle from the front plane, create the thin rectangle, define it, add the width, create the plate, okay? Then on the size of the front plane, I sketched these 2 rectangle, okay? Looks like has nothing to do with our object, but the reason is I wanted to define 3 points. 1, 2, 3, then I can use the spline to draw a curve. That's why. Okay, your rectangle doesn't need to be this shape. You can add more rectangle. Okay, the point of doing this is I can have 1 point, 2 points, 3 points defined. So then I can connect those 3 points to create the spline curves. That's it. All right. Okay, then I will add the spline curve. this side is straight. You can make it more complex. So I add this straight line, straight line. Now I have a quarter circular shape, sort of the scale leg, right? Then I added the thickness to the this direction and done. Once that's done, I copy the object once, twice, 3, 5 times in this horizontal direction. Then my bottom part is done. All right. Then to create the mold for this, I created the big box, slightly bigger block. Okay. Combine two of them, adjust the, moving this slightly, yada, yada, yada. Okay. All right. Now I have moved this lower scale leg part into this mold block. Once that's done, I can remove this part, save this as a assembly, because it has, as of now, I have two parts, right? Leg, lower bottom leg, bottom parts, and bottom mold, two parts in this assembly, save as assembly. Then I'm going to remove this cavity. Good. All right. Then once that's done, mold is created. That's the idea. All right. Good. Then that's it for today. All right. So, okay, I'm going to create this first, right? Okay. I have to create this plate first. Okay. All right. Okay. I don't need to save it. Okay, don't need to. Okay, start the parts. Start the parts. Okay, and using the front, look at this from the top. Okay. Again, at the origin is a good idea. And sorry for repeating the same thing again. Option. Okay, set the unit to be, I should set the unit MSGS as default. Good. All right, then I'm going to create a sing rectangle. Okay, dimension is 50 and 80 and add the thickness. Good. Good. All right, fully defined. So I'm going to add the width. Okay. So use this, extrude it again. Okay, and what was the width I added? Was 50. Okay. Right. Okay, done. Good. Right, then I'm going to add the scale like leg, right? So to do so, I created two rectangle. Okay, again, the idea is by doing so, I can define the 3 points. That's why. Okay, all right. Okay, look at this from the normal view. I use the usual rectangle. Okay, I should have drawn these rectangle using the construction mode, meaning turning into a reference line. As you can see, these are the dash line. Okay, so I forgot that part. Okay, all right, then do not click yes, check yet. Okay, what we have to do is we have to come here. This is very important. You have to say for construction. Okay, then this will turn into a reference line. Good. And one more rectangle. Good. All right. Okay, then we'll add the dimension. Okay, 3, 4, 5. Okay, location is 5. Okay. Okay, so I have defined 1.2.3. Now I can use this spline. Okay, spline is here. Select this. You have to go through 3 points. Funny, the line is not fully defined. I don't like it, so I'm going to redraw it. Okay. Location should be fully defined. Go through here, go through here. Okay, let me try. Good, I picked the wrong point, that's why. Okay, now this curve is fully defined. Again, spine requires 3 points. Okay, then I'm going to draw straight line here to close it. Right, I have an area. I can add the thickness. Okay, all right, then thickness should be 50. Okay, then let's add the thickness. Okay, let's see, thickness is added what direction? Ah, this is wrong. So you have to flip it. Okay, to flip the direction, use this one, reverse direction. Good. All right, then I have a leg. First leg appeared. Good. And you can keep repeating the same thing, but since we can copy and paste using the linear pattern, we will use the linear pattern in horizontal direction. Okay, I'm going to copy 5 of them, and spacing will be 12 and 5 of them. Good. All right. And that is called linear pattern. Okay. Direction is the horizontal direction. You can pick, oops, daisies. Okay, direction is horizontal direction this way. So you can pick any edge. This edge is okay, this edge is okay, this edge is okay. All right, so I'm going to pick this edge. All right, and I have to reverse this. Okay, all right, and 5 showed up, but clearly the spacing is too much, right? 50. So I changed to 12. Now I have 5, right? Including the original one. Then done. Good. Then you can save this as a bottom or scale bottom or whatever. Good. All right. Okay. Oh, let me save it. Maybe I should save it as a. Okay. I have the same thing, but I'll change this one as version 2. Okay. Then get out. Right. Now I have the bottom created, right? Then I would like to create a mode so that we can pour mixture to create this. To do so, first step is we have to create a bigger box, solid box, and squeeze this in, combine 2 of them as an assembly. Okay, put into the right location, something like this. Once that's done, we will create a cavity out of it. Good. Then you can have the mold. That's the idea. Good. All right, so first thing first, I have to create this block. 70, 100, what is the thickness? This part is quite straightforward and I have it already. I'll skip that part. Okay, let's move on to the combining the bottom, the leg I just created and the box. Okay, so that should be the assembly. Okay, all right. Then it will ask you, what do you want to import? Okay, I have already created the bottom and this and 2 of them in. Ah, okay. Oh no. No. I cannot do this. That was already maneuvered, so I cannot do that. Sorry, I still need to create the box. Forgive me for making mistakes. Okay, so that means I need to create the box again, this, okay. All right, here we go, parts, okay, and using the top plane, normal view, okay, origin, okay. I have to create the 70, 100, and thickness is 20. Okay, then I'm going to save this as a bottom mode 2. Previous one I just created was bottom, right? So save this as a bottom mode 2. All right. Okay, now I have 2 parts. Now I can assemble them. Okay. All right, here we go. Assemble. Okay. I can have this and this. All right, 2 of them import right away. Good. All right, 2 parts are imported. Okay, then I would like to set this surface to be same location. Then after that, move this one to the center. Okay, that's it. All right. Okay. Okay, boss is 10, 10. So and to make that happen, we should use a tool called mate so that this edge and this edge is aligned using the mate tool. Distance should be 10. Same thing, this edge and this edge should be aligned using the mate tool. Distance should be 10. And finally, this top and top surface should be mated so that it will become flat, right? Again, I forgot to change the dimension here. Okay, I saw this was already millimeter. Okay. Good, I can do it again. Okay. I just clicked 2 edges, so it's aligned completely, but that's not good. The distance should be 10, so it should be 10, right? Okay, done. All right. Okay, I aligned 2 edges, and let's see, I can use this one to be 10. Oh no, I cannot do that. So wire view, I can see the edges more easily. Okay, now it's aligned. That's wrong. It should be 10 millimeter away. Finally, the surface, right? Okay. I cannot see the surface, so I will go back here and change the transparency. Okay, go to advanced illumination. I'm trying to make the outside box transparent because otherwise I don't see anything. Okay, done. Oh, I changed this one. Oh, damn. I should have selected this one, right? Okay. All right. Okay. So many hiccups. Good. The final part is I would like to make this surface to the same location. Okay, mate. All right. This surface. Okay. Float it up. Good. So almost the end. Okay. Right now, two objects are overlapping. Okay. This is not empty yet. All right. And I think I have to save this as an assembly. Save as. Okay. All right. Good. Assembled. Right now it's in a weird situation, right? Two object is, solid object is sitting inside each, aligned in, on top of each other. Okay, so this is where I am. Okay, so the finally I would like to create this, make this as a cavity, right? To do so, I have select the mode. Okay, mode, edit component, and insert cavity. Good. Here we go. Mode, edit the component. Then I can say insert and modes and the cavity. And the cavity should be the, wait a minute, should be the bottom right. And I have to tell it the dimension, 3%. Good. And the bottom, okay. And this should be the bottom. All right. Now I have select this object to be a cavity. 3% here means the cavity will be slightly bigger, 3% bigger than this object here. Done. Okay, mode is created, right? So you just need to print this one out using 3D printer and pour the mixture, then you'll be set to go. Okay, before finalizing it, you have to click it, rebuild. All right, Okay, if you want to see the cross section, you can cross see this. Okay, and say, okay. Yeah, cross section. You can see it's nicely created mode. All right, then you have to save this as a mode, I think. Yeah, good. Okay, so far I finished most of them. Okay, most of them using this mode, pouring the mixture, you can get the lower part of the snake, right? Okay, lower part of the snake. Let me go back to the Professor Lin's picture. Okay, so this the snake model created by Professor Lin's team is lower part has this scale leg that I created, and I also just finished the mold to create this leg. Then later I will create the top portion with the air chamber, and also I'll create the mold. All right, thanks for coming today. It was a long day. I hope you don't have any questions. Okay, and hopefully my class note is detailed enough so that you just need to follow these steps one by one, and you can recreate the same thing. All right, good. Okay, thanks guys. Kind of early, but I'm done basically. Good. And I will see some of you tomorrow. Okay. How many of you are coming tomorrow? Oh, only one. Good. All right. Thank you so much. Okay. Bye-bye.